So welcome everyone. Today's session is about multi-factor designs. Split plot we'll probably spend the most time on, but a lot of these features apply to all of them. This is kind of a grouping of designs that are available within ARM. We want to kind of highlight the functionality and how to use them, and some maybe tricks and tips as we go as well. So I have some slides that we will come back to back and forth just to highlight a couple of newer features that have been added recently that pertain to this topic. But primarily here, we're just going to go over to our ARM. And I'm going to start by just creating a new protocol. And we'll work on a new protocol, and the first kind of the trick for multi-factor design and getting it set up is when you get to this new protocol step here. We have a few options. A lot of times you just click OK to get into the protocol and start working, but there is an option to go into the protocol settings here before we've established the file. And that's really the trick, I'll say, for the multi-factor. This will set up our treatments editor in a slightly different way for the multi-factor design. So one trick here is to go into the protocol settings before you've made it all the way into the protocol file when you're setting up one of these multi-factor designs. So general tab, everything's pretty much the same. We'll go right to the design tab here to point out that ARM has a fairly lengthy list of different study designs available. A lot of these are for different blocking schemes that you may have, Latin squares, lattices. They're completely random if you're not blocking at all. There's some augmented, kind of a whole host of different ones, but our focus today is going to be on these last four in the list. And these four are all types of multi-factor designs. We have the factorial RCB, a factorial CRD, split plot, and then a strip block. And so the multi-factor design is really where we're going to have maybe two different types of a focus for how we want to arrange our treatments. The example I'll work through today, although there's many different types, just a simple one that I'm going to talk through is that we have, we'll say, four different herbicide products. So make up their names. They'll probably be very boring, H1, H2, H3, H4 or something for our products that we're interested in. But we don't want to know just something about those products. We're also interested in how they perform on different tillage types will be the example I'm going to use. So I'll have three different tillage types, different practices, cultural practices, whatever you want to call them, that we're going to do throughout the field. And we want all four of those products to be on each one of those tillage types. So we end up with a multiplicative a factor there to say we really want those four products on each of those three tillage types. So we'll end up having 12 different combinations that we want to test. And so that's kind of the key with the multi-factor design is you want to do every combination of this and that. And that is really what we're doing with the factorial design. And so that brings me to our first slide here of what we've recently added. So previous to the latest ARM update, so prior to 2021.7, there was only one, what we called factorial. And that was actually a factorial with the RCB, or randomized complete block design to it. Well, oftentimes in like a greenhouse study, the desire isn't to have blocking. There is no need to block in a greenhouse, for example, because there is no gradient you may have to anticipate or try to protect yourself against. And so that completely random design, which we have in ARM for we'll call it a regular design, we have the RCB and the CRD. We kind of brought that flavor to the factorial as well. So now in ARM, you can run a completely random design with a factorial arrangement of treatments. So that multiplying we just discussed of that multi-factor type of look at your treatments can be performed, but when it comes to randomizing the trial map, there is no blocking. So treatments are free to show up at any place on that map. Because as in our example, it doesn't matter to us where that pot might sit on the bench. It's all a fair game in like a greenhouse. And so that we added that factorial CRD. And so then we needed to rename what we used to call just the factorial, because we only had one option in ARM for the factorial. Now we renamed it to factorial RCB, just to make it more clear now, since there are two different flavors, we'll call them, of the factorial. So this part here is relatively new to ARM. Hopefully add some flexibility for greenhouse studies in any other situation you might have, wanting to use a CRD, but still have that factorial approach to your treatments. So that is new. If that list looks a little different, so we now have the two different types of the factorial. Working our way down, the next option is a split plot. So that is the same approach to the multi-factor treatment look, but it's more of a restricted randomization, essentially. And it comes into play for the example we're using today. I had tillage type as an important, as one of our factors, one of the things we care about, because in a lot of cases, there's some sort of limitation to your design, to the equipment you're going to use to make the application, maybe to the location in the field, something where you're just kind of stuck and you can't totally randomize the treatments to be wherever they want to be within the block or within the trial itself. We have some reason, some pattern that has to exist just because by the nature of our design or of our experiment. And that's where then split plot comes in. So our example with the tillage types, the equipment's not going to let us, till just one tiny little plot, and then the next plot be something totally different. We're going to have to go all the way down the field with one type of tillage, and then we can connect to a different equipment and then come back the next pass and have that set, and have them each in their own area. So that's where the split plot comes in. And so ARM will assist us in the randomization. So when we get to the trial map later today, we'll kind of see how that impacts the trial map. And then when we get to the analysis, then as the analysis chews on our data, it can be aware of the way things are randomized. And so the analysis is also aware and can adjust for the way we've blocked and have that arrangement of treatments in our trial map. And then finally, the strip block or the crisscross is basically double split plot, if you will. So you have the one direction we had some sort of limitation. Now suddenly you have another as well. So that one's a little less common, but certainly just depending on what you're studying and the experiment itself, you might end up needing to do that. And so that would be another option there, kind of rounding our four different types of multi-factor designs. So for today's example, I'm going to use the split plot, but really pretty much everything that we show more or less will apply to really any of those different designs, those four multi-factor designs. So when we pick a multi-factor design, you'll notice that our settings dialog changes a little. We have a few more options to really fill in the multi-factor part of this study. So we'll choose the number of factors. And so in our case, that's kind of the number of things we want to multiply out. So our example today will be a 2-factor design with the tillage type and the herbicides. And so we put that information into these A and B, your different factors. So we have a drop-down list. If you want to choose a category from this drop-down list, there's a variety of them here that can be used. The bottom half of this list are actually the treatment type items from your treatments editor. So that can be useful as well, because then it will preload your treatment type in the editor. So for me, I think we will choose cultural practice for the different tillage type, and that will be 3 different levels. So that will be the 3 different types of tillage that we have is our main unit, our factor A. And then for factor B, we said, I chose herbicide product, whatever type of product you might be working on. And we said we have 4 of those. So I'm going to set that to 4. Something new here that wasn't here before is the level description. We'll come back to that here. Once we've filled in some treatment information, then this will make a little more sense. You can see it's blank right now, but once we go into our treatment editor and fill in some details, then ARM can pre-fill that table. So we'll kind of come back to that later on. But that's about it for what's majorly different in a multi-factor design from a setting standpoint. All of the other sections here in the protocol settings are really the same in any type of design. So now that we have set the number of levels for our factorial design, we can say OK. And now when we press OK to go into the protocol, we will see that our treatments editor will look just a little bit different than a RCB or another design. So here we have in our treatment editor a few different sections actually to fill in the treatment list. So we have a section to fill in details for our factor A or our cultural practice, as well as a section to describe the different levels of our factor B, which in our case is our products that we're looking at. And then finally, we have a section for comparison treatments. So the comparison treatments would be any treatment that is not part of the factorial, but maybe is present as if it's an untreated check or a reference product or something like that, that's just kind of hanging out. It's part of the study. It's going to be included there on the map, but it's not part of the multi-factor design. So there's the flexibility to add that. I think it's pretty rare. A lot of times, of course, your main analysis, which we'll see later on in the reporting, if you want to do that multi-factor analysis, then comparison treatments will not be included with that analysis. Those are dropped out automatically. So I think it's somewhat rare to have, but I am going to show we'll include one comparison treatment just for an example, so you can see what does happen to that comparison treatment. So we fill in these sections just like we would in a regular trial or regular protocol. In my case, maybe I'll make my comparison treatment that untreated check. just so we can see what functionally happens. A lot of times, even if you have an untreated, you may want to include it in your design. So in my case, if I really wanted to kind of compare my herbicide products to an untreated check, it might be wise to have my first level of factor B be the untreated, so that there's an untreated plot for each different tillage type. So I think again, it's kind of rare to have a comparison treatment. What you're most interested in, typically you want to get into your levels of that multi-factor, but we'll just have an untreated kind of hanging out. So we can fill in the details here for our different sections. So here we want to describe factor A, and in this case, being a tillage type, there really is no application of that. There's no formulation or rate or anything like that. But it's kind of a best practice to, at least use the treatment name to give this component a name. So of course, I'm going to be very unoriginal and just call it tillage 1, tillage 2, tillage 3. Of course, there'd be something actually interesting, a real name you could give to each of those types of tillage. But you do want to at least give it a name, even if it's not strictly a product that's being applied, because as we see then when we combine and fill in the full treatment list in the trial, we'll be able to see that product number 1 will be applied with tillage 1. And then the next treatment will be product 1 with tillage 2. So you'll have multiple components for those proper treatment numbers. And so having that name there then will provide that information. So I'm going to be pretty brief and unoriginal here in giving all of these names. Obviously, in a real study, we'd fill in the formulation details, the rate, the application information for when those products are applied, things like that. But in our example, we'll just keep it simple. But you want to fill in the details for these different levels. It is possible if you have one of these components has multiple one of these levels has multiple components. For whatever reason, maybe this has an adjuvant with it, or whatever the case may be. It's certainly possible to have multiple lines, multiple components for a particular level. So just like the regular treatments editor, that functionality is all there as well. So that is, basically the end of the differences. Again, in a multi-factor design, you'll see everything else is the exact same in a multi-factor protocol. All of your protocol description sections, there's nothing hidden or visible or extra really in any of these sections, anything different in the assessment data. Things are exactly the same. There's the setup of the protocol is really the same no matter what design you've chosen. And really the differences will come when we go to randomize. The map, of course, for whatever design you've chosen, ARM will help to choose a randomization that fits that design. And here in the multi-factor, of course, we have the different treatment editor. But that does bring us to another new feature that we can take advantage of now in ARM. And it's the option to multiply out treatments. So as we discussed, the whole idea of the multi-factor design is to have every combination of each treatment. And so the protocol always has had that factor list that you fill in. And then once you got to a trial, you would have this full multiplied out list of treatments. Well, now we've added the ability to see that list and really create that multiplied out list while you're still in the protocol. So I've got a video, but it's pretty much going to cover the same thing we have here in ARM. So I'm going to skip over that and we'll actually do it here in this protocol. So under the Tools menu, there's an option to multiply out treatments. So when we perform this, it is kind of a major action in the study. So right now I'm saying I'm going to need to save the file, and we haven't done that yet. So let's just save this, and I'm just going to throw it onto my desktop for now, and we'll call it the split plot webinar. Obviously, yours would be much more official than that, but so we saved the protocol just because we really needed to do that before we carried on. But now you can see that our treatment list has changed, kind of to that typical list that you're used to seeing, and what we would get in the trial when we created the trial. So now what we have is that multiplied list. We've got the first tillage type with our first herbicide, and then that same tillage type with the second, third, and fourth product. And that makes up the list of the first 4 treatments. And then we continue on with the second tillage type with all 4 of our different products. And then finally, the third tillage type with all 4 products. So we end up with a total of 12 treatments that are in that multi-factor design. And you can see our comparison treatment then is just kind of hanging out at the bottom. And of course, a real study would have much more information here in the treatments editor. But you'll notice then at the far right side of the screen, we have the 2 new fields that weren't here a moment ago, and that typically only exist in a trial, and that is the factor ID and the level number. So those came from that original setup where we were listing out the factor A information and the factor B information. Now we kind of have that reference of where that came from. And so this was the first level of factor A, the first tillage type we defined, and this was the first product that we defined, et cetera, et cetera. So that information is here, again, just like a trial. So one gotcha with this multiply out treatments is it's not something that you can go back and forth on. So if I save and close this protocol the way it is, then it will stay this multiplied out way. We can't go back to the format we had before. If you're still in that same session when you multiplied it out, you can utilize the undo. So I've used this a couple of times on support calls when we're kind of working through and trying to set up a design the way they want to. And we say, all right, I think that's right. Well, let's multiply out the treatments and just make sure that list looks like what we'd want in the end. And we say, yep, that looks good. And then we say, okay, well, we'll just use it as kind of a confirmation step, and then I'll just undo. And then it'll put the list right back the way it was. So that's one approach. If you just kind of want to use the multiply out as kind of a quick check, all right, did I set this up right? Is this going to give me the list I need when we're in the trial? That's a slick way to do that. Or of course, you can leave it the long way too. Either one will work. Another example where this really where the feature came from as far as a real need to be able to multiply it out in a protocol, that would be here in this video. The example I give is we have different products that are being applied, and they each product has a different rate. We call it really a different base rate that the product would be applied at. And so I made up 2, 3, and 1.5 pounds active ingredient per acre. But the design itself was to really look at the different rates. So we wanted to apply each product at a low rate, a medium rate, and a high rate. And really that was a multiplier then. So we really wanted to have the base rate of 1, and then have it be 1.5 times the base rate. That would be kind of your medium setting. Then let's double the rate, and that would be the high level to apply it, and see how each of those products performed at those different combinations. So the trouble with that approach is then that you couldn't get the right rate when you're filling in this format. So here, see if I can go full screen. There we go. And I'll just skip ahead again. Hopefully it's a little bit easier to see then. Once you multiply out the treatments, this would be once you get into the trial, this is what you would see. We would have our 9 different treatments. Each treatment at a low, medium, and high rate. But the problem is the treatments editor isn't accurate. We'd have that accord at 2 pounds active for each section, and we'd have to manually kind of apply that multiplication and try to hope if you're just the sponsor sending this to the trialists, hope that they understand the system and what actually needs to be done. So a little bit messy, not being able to control that. So by using this multiply out treatments, we can get to this list while we're still in the protocol. And so that way in this example now, we can multiply it out and clean up the list to be what we truly want to have. So here now, while we're still in the protocol, before we sent it out to any trialist, we can make things clean and simple. And so, clear out that extra rate information and now actually adjust the rate for each line of that product. So that way now when we print our spray sheet, we'll actually have the right amounts being calculated. And it's very clear at what rate each product should be at. But we still have the multi-factor design. This is still a protocol, so we can send it out to our trialist to perform. So that was the main scenario that drove this development, but I think it's useful for a couple of different purposes. But again, this is kind of the reason why once you've multiplied out the treatments, you can't go back just automatically. Because of course, now that we've changed all this information, there's no way ARM can put it back, the way it was. So that's the one gotcha, if you will, for that. All right. Well, any questions on the protocol? That really covers kind of the first half, the first side of the multi-factor designs is setting up the protocol. Here we'll move on to the randomization and see the trial map. But that's really this kind of the first component of just getting that protocol set up. All right, so we've got our protocol defined. Of course, it's very empty and not a whole lot of exciting information, but we'll just carry on into creating a trial. Suppose I didn't enter an ID, so we'll just make up one on the spot here. So now the trial map, we have a little bit more information to show on the trial map for a multi-factor design. And specifically, remember, we chose split plot. So we have a little bit more to look at even here on the map. So typically, when you see the trial map in a standard trial, this is what you would see. It's colored by the different treatments. And of course, you're just kind of looking to see how dispersed those treatments are. You don't want to cluster things too close to each other, etc. But in a multi-factor design, you'll notice we had it colored a little differently. We can color by the factor levels. And in our case, we're looking at that factor A, which was our tillage type. So because we chose the split plot design, then if we focus here on just this first replicate, so plots 101 to 113, in a factorial RCB design, we could have treatments appear in any order across that block. It does not matter, and they would be chosen at random. Because we chose the split plot, that design says I need to have all of my factor A1s together, and all of my factor A2s together, and all my factor A3s together. In our case, our tillage types. We can't just willy-nilly choose our tillage types. They're going to have to be all four of those plots right next to each other in the field, so that way my equipment can get that area across, and then the next will hook up to the other equipment and perform that other type. So that's why we have all of these A2s together. Within the A2s, now the Bs, which in our case are the products, the choice of where those products are in this group of four, that is free to be random. So 2, 4, 3, 1 is the order for this first group, or they call it a main unit, is this set of 4 here in our case. And then this next main unit here, 3, 2, 1, 4. So you can see that choice is free to be different throughout, and then 4, 2, 3, 1. So we have no restriction on how those products can be applied. So there is still some randomization to it. You may notice, for our example, we said the tillage, of course, we're going to need across the whole map. We're going to have all of them together. But within each replicate, you'll see the choice of whether A1 or A2 comes first can differ. We actually got pretty close to having A2 be all in one shot just by chance, but obviously that didn't happen for all of the sections. So we do have an option to control that if necessary. So if I go into the settings, it'll take us to the layout tab. And the last option at the bottom, we have the ability to not randomize one unit for a split plot design. So we can say that I do not want to randomize the tillage types in each replicate. And what that means is A1, our tillage type 1, will be the first chosen one in each replicate. And then the A2 will be in the middle, and then A3 will be on the right. So now we have that arrangement just based on the requirements for our experiment, whatever has to happen. In this case, our equipment is dictating that this is really the only practical way to perform this trial. And so this is how we will arrange the treatments. Again, if we color by factor B, we will see, again, there is some randomness to this, of course. So it's not like we're just playing everything out in strips entirely, but we are limited. And so being able to put this in a design in ARM, of course, speeds up being able to choose this map in the first place. We can have ARM set the randomization for us. And then we'll see in the analysis at the end as well. Now, ARM is aware of what we had to do with the map. And so we can make some specific choices and selections within the analysis. I guess I shouldn't say we are making that selection. ARM will automatically have the right choices in the analysis it does to be aware of how things were set up. So a couple of advantages this way of having ARM dictate to ARM what the design is and what we had to have. So most of that was specific to a split plot, you know, having these groupings next to each other. But certainly in a typical multi-factor design, there's more flexibility, as we had talked about with an RCB. We'll still have this block of 13, but the treatments within there can be wherever they want to. If we had chose the factorial CRD, then anything could be anywhere. We wouldn't have the blocking at all. Be completely random across there. Now, one question which I didn't highlight yet, this treatment 13, you'll notice that doesn't have any A or B designation. That's our comparison treatment, our check. So that is not randomized at all. It ends up here just on the right side of the map. We don't have a specific option to kind of control the behavior or where that goes. ARM will just kind of throw it to the edge. But once we get here, you certainly can manipulate the map if you need to. So let's say we want to distribute these checks maybe a little bit more across the field. Of course, we still need to keep this grouping of all the A3s together, but maybe we should insert a column. When I clicked here, so let me insert to the right. So we'll have an empty column. Oh, I clicked at the right and that put it all the way over here. So that didn't make any sense. Let me turn off this option here and insert a column. This will insert an empty column here between 408 and 409 all the way down. And then we can auto select for move a particular plot. So maybe I want to say, all right, well, let's have in the first replicate, maybe put the untreated here. Maybe we insert another column here and we can move to 213 here and maybe just every other replicate, something like that, just so they're a little bit more, included in the map, if you will. So you certainly have that ability, that flexibility in setting up the map. And then I could just delete these empty, oops, I clicked row, delete empty columns. Delete column. You'll notice the trial map is just a little bit slower when working with a multi-factor design. We have so much more information on each of those plots. It's just a little bit slower. I guess while we're talking about moving the map around, you'll notice the auto select for move. There is another option for moving components on the map that isn't there in a regular, like an RCB design, and that's to auto select a main unit. If I click on plot 101, you'll see it'll actually select this whole quartet of plots, all of these A1s together. So again, for a split plot, that's important. Those have to stay together. Of course, in our case, we have really no choice as to where they go when we chose that option to kind of automate that selection. But let's just say, maybe I'll go into my settings and we won't not randomize one unit, and we'll get a brand new map here. So if we were in a multi-factor, Could even be a split plot, but you have maybe a little more flexibility that it doesn't have to be the same across the whole map, but we just want these grouped. You can control then with select for move to put things where you want them. So you could manually, without that option, I could drag and drop these entire sections and line them up this way. So now in our case, A1, A3, A2, just by chance, maybe if you prefer it to be a little more random, that could be the approach you take as to which order they end up next to each other. You have that flexibility with that main unit choice here for the auto select for move. Again, that's kind of the multi-factor, the split plot flavor here coming into the trial map. Great question. All right. Last thing to point out here on the map, we have a level description. So in every trial, there is a treatment description that gets built for each treatment. We kind of congregate some of the details from the treatments editor, put them together here to give a nice simple description of the treatment. We do the same thing with the level description. And so we have, again, we kind of took from the treatment name section of the treatments that we filled in. Certainly, if we filled in like the rate or some more details there, we can control and bring in even more information if we wanted to. But in this case, it works just fine with what we have. So that description gets built kind of automatically from what's in your treatments editor. And then the level code ends up just being, you can have 3 or 4, can't remember how many characters we can have. I guess it lets us do a few more, but from a practical standpoint, you can display this level code on the map. But from a practical standpoint, 3 or 4 is about all that map can handle, and those plots just get so tiny. But that can be kind of a shortcut. You can see you can adjust this as you want. So here, maybe I would want to shorten these up a little bit and put our numbering. Oops. And then in the options, you can display the factor level code instead of the A1, B1 information. Maybe it would mean a little more to you instead of the arbitrary A's and B's. You can use that code. In this case, oh, it refreshed on me. We had typed in the T1, P4. That was just the codes that we had typed in. For whatever reason, it refreshed on me. But of course, now as I make a change, it's going to kind of redraw everything. But so this level description is here in the trial map. So it can be adjusted, of course, once we get into the trial file and save the trial file. It lives there and can be adjusted. One change that I'll highlight here, I guess I don't have a separate slide specifically for the fact that it now exists. If I go into settings, this was that section in the protocol settings that we saw. We have that level description. So in previous years, this was not there. There really was no way to change or populate the level description until you got to the trial map, until you generated the trial. So just another tool in the toolbox for the protocol writer designing these multi-factor designs is to have this level description available in the protocol. So if you make any changes here, then it will be reflected when the trial is generated and when all of the trials are generated. So the level description being here on the trial map isn't new. That's been there for a while, but now having that ability in the protocol to fill that in or adjust it, that part is new. All right, so that is the trial map. I'm going to accept current to move on to actually, creating this trial file. We could save it here. I'm just going to dump it on my desktop again. You'd want to save it to a real location. But now we're in the trial. We've got our full list of treatments, just kind of like we saw a bit in the protocol with our factor ID and level number. And again, we'd have all the real treatment information if we took the time to fill it in. And again, we can draw that trial map. So you can come back to this trial map when you're in the trial and make any adjustments, just like a typical trial you would be able to. All right, so that's the trial, setting up the trial map. Last component would be the analysis. So I'm going to close this trial that we've built just because we don't have any data in it, and it's a little bit faster. If we just switch over, I'm going to enter the tutorial list just to grab a split plot design that's in here. So we have a GAll split plot two-way. I want to make sure it's the trial file here. And I will open that up, kind of a quick shortcut. And then this example is closer to what is kind of the one we had in the slides, where we had 3 different products at the 3 different rates, the low, medium, and high. So that's what we ended up with here in this study. So, and then there is an untreated check at the bottom. So we have that example of that comparison treatment and how it behaves. So for the analysis, we will go into the print reports, and the multi-factor designs, instead of using the AOV means table, we have a factorial AOV table instead. So this is kind of this special analysis for the multi-factor design. A lot of similar options. The report itself is similar in structure to the AOV report, so it shouldn't look too unusual. Let's just go ahead and say next here to preview the report on the screen. We'll see what kind of options it looks like it's going to prompt me to choose header line numbers. We'll just grab the PES code, rating date, rating information, and action code. All right, so let's preview this report on the screen. All right, so the general structure is similar to an AOV report, that we're going to have all of the data columns across the width of the page with the header details. So we just selected the rows of the header details for those columns. But now instead of just our list of treatments, we get to look at a few different cross sections of the data. So the first one here is the table of replicate means. So there's just replicate means, no analysis included with that, but can give you just kind of a glimpse at the replicates that were chosen or that we ended up with, how similar they performed or not. The next section, I'll zoom in a little more here. Maybe we don't need to see all of the columns. Next section is the table of A means. So this is really our first cross section, is to say, let's look at each of our different factor A levels and see how they performed. In this case, it's our products. So we have our 3 different products, and the mean here is combined across the different rates, across the different B levels. So for this design, it's really, okay, how did this product perform against the others irregardless of how much product at what rate was done. Combine all three of those iterations and see just as a whole how that product did. So we get the average of those three unique treatments in the list combined here into the one value, and then we perform a mean comparison test and have some statistics there with that. And again, that's done for each assessment column. Then we get to see the other cross section. Okay, I don't care about what product was done, but let's just see how the rates performed. So this is rate 1 combined across the 3 different products that we had. And then the medium rate and then the high rate. Again, then we get the mean comparison with the statistics, the AOV that's performed. And then we have all combinations of A times B. So kind of the more traditional treatment list, essentially, of every combination with the mean comparison and the statistics. If I go to the next page, then we get to see the factorial AOV analysis. So this is where we kind of talked about that choice in the design tab, then will give us kind of a specific analysis in the end. So we can see all of our different sources of variation and how the analysis split things up. One interesting value that might be of particular importance or interest would be the AB row here. There's a p-value, and so this would give you a sense of whether there was interaction between those two factors. In our case, is there an interaction between what product was being applied and the rate that it was applied at? And in this case, it's very significant that there is a difference. And that, of course, is by column. So this is data column 1, column 2, column 3, etc. So depending on the most important assessment, and it looks like, I don't know if we have a yield. Most of these are just control assessments, but pretty consistently they're all significant. So just depending on your desired outcome and what you're looking at, that can be pretty important to make that distinction, make that choice there, or again, coming back up to the top and just getting to see how things performed on those different cross sections. I mean, kind of the two biggest differences, kind of the new things you get with the factorial report. And you'll notice nowhere on here is there a mention of that untreated check, that comparison treatment. So that treatment was completely ignored in this analysis because it's not part of the factorial design. If you do want to see, okay, well, what was the point of bringing him along then? I'd like to at least see a comparison of the products with that, in our case, untreated check or whatever reason for that comparison treatment. It's certainly valid to run an AOV means table if you'd like. Essentially, you're kind of downgrading the design of sorts to look at the results as if it was just an RCB design, is one way to think of that. I'm just going to preview here on this page just to show that that's certainly valid. There's not going to be any flashing lights in the air to say, hey, you can't do this. It just runs the treatments kind of straight, if you will, that there's no special consideration for the way they're arranged. It's just treatment 1, treatment 2, treatment 3. How do they stack up against each other? And you'll see that at the bottom that we just so happen to fall into the next page. Let me hit next and we can shorten this report just a little bit with our header selection. So that way on the page, we'll see all the treatments are all being analyzed together. We just got unlucky basically that it fell off on, well, we still got unlucky, it fell on the other page, but that's because I'm in landscape mode. Let's switch over to portrait and see if we can get a decent, there we go. Now a better illustration. We've got all treatments 1 through 10, even that untreated is present. Looks like it doesn't have a mean comparison because I have the EC to exclude the check from the analysis. So I'm really butchering this example of showing the untreated check in here, but AOV table will bring in all of the treatments. The comparison treatment will, without any choice, will not be included in the factorial report. And then just to wrap things up, the last section here, the last kind of new feature in ARM that's been recently added pertains to the reporting. So that factorial report. Previously, we always just brought in treatment information, just like on the AOV report, where you choose the treatment fields to print and the different columns are coming in. Now we have the ability on that factorial report to use the level descriptions instead. So this will affect that factorial AOV table we just looked at. Also, if you're doing a treatments report in a multi-factor study, then you can use this same option will apply. So it's going to use that level description that we had filled in. Let me go back here, and actually we should open the trial map since this is a slightly different study, just to see. Looks like our map might be slightly large for my screen here, but I don't think it's too huge of a study, so it should work out. So here's our descriptions that were built in. And those can be used instead of choosing, for example, what we would end up with formulation information and maybe a rate, whatever we'd have on that report. Going back to that factorial AOV table, it's this multi-factor view. We can use the level description, which we had saw there. So that was the simple accord, Brahmanal, and Canon. Notice there's no treatment information. We just used that nice, short, simple description that we had. If you like the old way, don't want to change it, then you can utilize these other options here. Typically, these are the same unless something was entered in the protocol, and then once you created the trial, if there was a change afterwards, then that's the difference between those two essentially. If you needed to go back to what was always in the protocol. But here now, choosing that option, now we have the treatment name, rate unit. Again, you can specify whatever components would be included there. So that's the previous approach. But by default, the level description will be chosen. All right, so it's 10 o'clock. I do have one question here, just a real quick cover. There are a couple of options on the FAOV table section. There is the use FAOV, trying to find where that is. We have the only one significant AOV is the the protected test. Let me look at all of my report options to see if I'm overlooking the one referring to the complete error. Wonder if that one's turned off because we're in a split plot. That's on the AOV means table report here. Yes, so on the AOV means table report, there is an option that pertains to the factorial. So this option to use the FAOV complete error for split plot trials. So that's a lot of statistical jargon for that basic approach that we mentioned, where the analysis can be, we can have the analysis be aware of our restrictions in the split plot trial, essentially. So that's really turn that on to say, hey, if I'm in a split plot trial, I've told ARM that we've got these limitations and this is the way it's designed. I'd like the analysis to also be that smart and include that, factor that in to its decisions and its procedures in the analysis. Would be maybe a layman's term, a non-statistical way to describe that. If you have that off, then essentially we'd be telling ARM, I don't want you to consider the way I've arranged the map, the arrangement of the split plot part of that arrangement. I don't want that to be factored in. Just shoot it straight, just have it behave as if everything was just randomly placed there. So that's kind of the decision there. And then the only when significant AOV treatment P of F, that's not specific to a multi-factor design, but just a general utility here for the mean comparison test. And basically that means that if we do a report preview here quick, we will tell ARM, don't even bother running a mean comparison test if the AOV analysis doesn't detect differences. So here it's going to look at the treatment probability of F. If that value is not significant, then don't run a mean comparison test. So that's not too specific to a multi-factor, but is important to know. They call that a protected test. I think that basically that same option is available on the factorial report, the only when significant. So you have that same option available in the multi-factor report as well. All right, great question. Well, we've reached the end of our time. I appreciate everyone joining us today. If you do have a question, feel free. I've got a couple minutes. I can hang on the line if you needed to, but don't want to hold anyone hostage. So appreciate you all joining us today, and hopefully we'll be seeing you at another webinar soon. And next week we've got one more on our series for protocol writing. The last one of that group talking about study rules. So that'll be next Tuesday. So thanks, everybody.